cover radical equations and inequalities. We've already been solving radical equations for a couple of weeks now, and the easy ones you can isolate a radical and square both sides, and then follow basic algebra 1 steps from after that. So I'm not going to bore you on the easy problems because I think you're better than that. So here we have square root of x minus 12 equals 2 minus the square root of x. So the same principle applies. We want to isolate a radical and square both sides. The problem is we have two radicals in this equation, and we can only isolate one at a time. So currently there's already one isolated, so we're going to square both sides. Notice that squaring both sides doesn't mean I square each thing individually. So to square 2 minus square root of x, I have to multiply out 2 minus root x times 2 minus root x. And you can multiply this out just like you would any binomial. So 4 and then 2 minus root x is, or 2 times negative root x is going to be minus 2 root x. And then we did that one. No, we didn't do that one yet. We did this one. So that's 2 minus root x. Here we have another minus 2 root x. And the last one, if we multiply negative root x by negative root x, the square roots cancel out and we just get plus x. Because root x times root x would be x. That's root x squared. And then this becomes 4 minus 4 square root of x plus x. Right? And then the left side, the squared and the square root just cancel out. So we get x minus 12 equals 4 minus 4 square root of x plus x. And then from here, notice our original equation had 2 square roots, and this equation now only has 1 square root. So I'm going to get that square root on one side by itself and then square both sides again. So I can subtract x from both sides, and conveniently that cancels out. And I can subtract 4 from both sides. So now I have negative 16 equals negative 4 root x. And I can divide both sides by negative 4. And we get 4 equals the square root of x. And then we square both sides. So we get 16 equals x. But a curious thing can happen when we deal with these square root equations. When we square both sides of an equation, we're changing the domain of our original possible solutions. So when we plug 16 back into the equation, so when we check, if I do the square root of 16 minus 12, and then 2 minus the square root of 16, on the right side, on the left side I have square root of 4. On the left side I have 2 minus 4. So the square root of 4 is 2. Square root of 4 is 2. And 2 does not equal negative 2. And this is because we're only taking the positive square root of 4. If it was implying the positive and negative square root of 4, then both would be written. So what that means, since 2 does not equal negative 2, 16 is an extraneous solution. And remember, we had these way back at the beginning of the year when we dealt with absolute value equations. So no solution. And x equals 16 is extraneous. All right, so number 2 here. Here we already have a radical isolated, and we only have one of them, so we square both sides. So this gives us x minus 2 equals, remember, to square x minus 4, that means I have to multiply together the two binomials using FOIL or whatever you want to call it. And that would give me x squared minus 8x plus 16. Now, notice that our resulting equation is quadratic. There's an x squared. And the only way we can solve quadratics is to set them equal to 0. So we subtract x and add 2 to both sides. And we get x squared minus 9x plus 18 equals 0. And then this equation we can solve by factoring. So we need to find two numbers with a product of 18 and a sum of negative 9, and that would be negative 6 and negative 3. So this factors to x minus 6 times x minus 3, which means that x equals 6 or x equals 3. And we still need to check both of these solutions. So if x is 6, then square root of 6 minus 2, does that equal 6 minus 4? And then 6 minus 2 is, so the square root of 4 does in fact equal positive 2. So this one works. So x equals 6 is a solution. Now if we check x equals 2, so the square root of, or x equals 3, so the square root of 3 minus 2, does that equal 3 minus 4? And here we get square root of 1, but on the left side we get negative 1. So these are not equal. So this solution is extraneous. Meaning x equals 6 is a solution and this one is not. So when we solve these square root equations, anytime we square both sides of an equation, we have to check for extraneous solutions. So on to page 2. Here we have 2 times 6x minus 3 to the 1/3 power minus 4 equals 0. And here it's helpful to remember that raising something to the 1/3 power is just the same as taking the cube root. So it really is more helpful to write this as the cube root of 6x minus 3. And if it's okay with everyone else, I'm going to add 4 to the other side. So 2 times the cube root of 6x minus 3 is equal to 4. And here we can solve it like any radical equation. We want to isolate the radical. So the cube root of 6x minus 3 equals 2. And then the opposite of the cube root is to cube something. So I'm going to cube both sides. So 6x minus 3 equals 8. And then I can add 3. So 6x equals 11. Divide by 6. We get x equals 11 over 6. Now, it's not a bad idea to check, but when you cube both sides, when you cube something, it doesn't actually change the domain of the original solution set. So cubing both sides won't result in extraneous solutions, as it turns out. So here, not that it's a bad idea to check, but if you did your algebra right, it should work out. That's for cubing both sides. So if you square both sides, then you do change the domain, because a square root can't have negatives inside, but a cube root can. Here we have 3 times x minus 2 to the 2/3 is equal to 12. So just like the previous problem, we're going to want to write that rational exponent in radical form so that we can see its inverse better. So first, it helps to divide both sides by 3, of course. So this is, whoa. So this is x minus 2, the cube root of x minus 2, and squared equals 4 after, dividing both sides by 3. So from here, I can get rid of the square root I can get rid of the squared or the cube root in either order. It doesn't matter. But just for the purpose of making the numbers smaller instead of bigger, I'm going to elect to get rid of the square root first. So that means I square root both sides. But when I square root both sides, I need to plus or minus. So that's going to give me 2 solutions now. I can have the cube root of x minus 2 equals 2, or I can have the cube root of x minus 2 equals negative 2. And then I have to solve both of these separately. But I solve them the same way. I'm going to cube both sides. So that gives me x minus 2 equals negative 8. And here, if I cube both sides, I get x minus 2 equals positive 8. So then I get x is equal to 10, and x is equal to negative 6. And the nice thing here is, so we get extraneous solutions if we square both sides, because squaring both sides changes the domain, like I said earlier. But cubing both sides doesn't change the domain. So as long as we did our algebra right, both of these solutions work. And you can verify them for yourself. 10 minus 2 here would give us 8. And then the cube root of 8 is 2. 2 squared is 4. 4 times 3 is 12. And for negative 6, we can write it out. Negative 6 minus 2. We're going to have the cube root of that, and it's going to be squared, and times 3. So negative 6 minus 2 is negative 8, And the cube root of negative 8 is negative 2. So this is 3 times negative 2 squared. And then negative 2 squared is still positive 4. So 3 times 4 is 12. So we do have two solutions from this equation, and neither one is extraneous. Problem 5, we have a square root inequality. So we know to solve an inequality, for a lot of it you can treat it like an equation, but for square root inequalities there's a twist at the end. So we'll start by, adding 2 to both sides. So we get square root of 4x minus 4 is less than 6. And we can square both sides to get 4x minus 4 is less than 36. Add 4. And we get 4x is less than 40, which means that x is less than 10. But that's not the entire solution, because with square roots, we know that at some point there's a minimum value that can be inside the square root. We can't have a negative inside the square root. And because the inside of a square root can't be negative, we also have to solve for when is the square root function greater than or equal to 0. Because the inside of the square root can't be less than 0. So when we solve this, we would get 4x is greater than or equal to 4, and x is greater than or equal to 1. So what that means is 1 is the absolute minimum value that can be inside of this square root. Because when x is 1, 4 times 1 is 4, and 4 minus 4 is 0. When x is 1, the inside of the square root is equal to 0. If x is any number less than 1, the inside of the square root is negative, and this expression doesn't exist. So what we have is x has to be greater than 1, and x has to be less than 10 to satisfy the inequality. So altogether, that comes out to x is between 1 and 10. So normally you would write that like this. So if this original equation had been greater than, so if this had been a greater than sign, then we would get x is greater than 1 and x is greater than 10. So you'd only have to write x is greater than 10. You can also end up with cases like this where there are no solution, where the inside, like your square root value has to be greater than 1, but then you get that your solution is less than negative 1. So in that case, you would have a no solution. But here we do have a solution, and it's x is less than, x is between, and notice this is less than or x is greater than or equal to 1, but strictly less than 10.